Hello everyone, here is a question from quantum mechanical model of atom. Which ion has the stable electronic configuration Ni2 plus or Fe3 plus? Let us first write down the electronic configuration of both of them and then we will decide which one is more stable. To write the electronic configuration, we need to follow the aufbau principle or the build up principle. The easiest way to do is write the orbitals like this: 1s, 2s, 2p, 3s, 3p, 3d, and then 4s, 4p, 4d, 4f, and then put a slanting line like this. Start from here, end here. Start here, end here. So that it's easy to remember. The atomic number of nickel is 28. So let us first write down the electronic configuration of nickel. In a neutral element, the number of protons must be equal to the number of electrons. This means nickel has 28 protons and 28 electrons. So let us write the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2, and then after 4s2 we are going to 3d. In 3d we should have only 8 electrons, because until here it counts to 20, isn't it? 20 electrons and then plus 8. So therefore 28 electrons. Now if we say nickel 2 plus, this means we remove 2 electrons. Now the number of protons will be the same, but the number of electrons will be 26. Electrons must be removed from the outer orbit. Here the n value is 4. Therefore electrons must be removed from 4s2 first. Therefore the electronic configuration now is, we can simply put it this way: argon, that has 18 electrons until here, that is argon, atomic number of argon is 18, and then the 2 electrons from 4s2 they are removed now. Therefore 3d 8, and the 3d electrons, the 8 electrons can be filled this way: 1, 2, 3, 4, 5, and then 6, 7, 8. Now let us write the electronic configuration of Fe3 plus. For Fe, let us first write the electronic configuration. Atomic number is 26, and therefore argon, that has 18 electrons, and then 4s2 20, and then 3d 6. Now if we say Fe3 plus, this means now the number of protons will be still 26, but the number of electrons will be only 23. Therefore for Fe3 plus it will be still argon 18 electrons. Both the electrons from 4s2 will be removed now, and 1 electron from 3d6 will be removed. Therefore this will become 3d5. We have 5 electrons in the 3d orbitals here for Fe3 plus. This electronic configuration is more stable than nickel 2 plus, because this is half filled. It is symmetric and the exchange energy is more. So in general, half filled or completely filled, that means D10, half filled or completely filled d orbitals are more stable compared to partially filled d orbitals. What we have for nickel 2 plus is 3d 8, isn't it, which is partially filled. So we have 8 electrons there: 1, 2, 3, 4, 5, 6, 7, 8. So this is partially filled and not symmetric, whereas this one is half filled and completely symmetric. Therefore Fe3 plus is more stable than nickel 2 plus for two reasons. One is symmetry and the second is exchange energy. What we mean by exchange energy is when we have two or more electrons in the d orbital with the same spin, there is a possibility of exchanging their positions. For example, this electron, let us say this is the first electron, instead of going here, it can go here or here or here or here. That means 4 different exchanges are possible. Likewise, when the second electron comes in, 3 different exchanges are possible. Then when the third electron comes in, 2 different exchanges are possible. Then when the fourth electron comes in, 1 exchange is possible. So therefore, overall 10 different exchanges are possible when we have half filled d electrons. Whereas here only 1 exchange is possible. Instead of going here, it can go here because this is already paired up. So therefore, only 1 exchange is possible here. But for Fe3 plus, 10 different exchanges are possible. Therefore, Fe3 plus is more stable than nickel 2 plus.